Welcome to the MSBT online learning platform. We bring you the most relevant content in an exciting digital format. Today we will be studying a very interesting module from Applied Mechanics which include topic Mechanics and Force System, where we will be studying some interesting facts about mechanics and force system. We will be practicing some of the example based on it. So let us begin. Dear students, today we are going to learn module Applied Mechanics, topic Mechanics and Force System. Objectives: to understand significance and relevance of mechanics, to know importance of mechanics, to understand basic terms in applied mechanics, to know basic quantities with their types, to understand concept of force and force system, to know the principle of transmissibility of force. Learning outcomes: know the concept of mechanics with its significance and relevance. Know importance of applied mechanics study with some examples. Understand the basic terms in applied mechanics. Understand physical quantity with their units. Understand physical quantity with their types and examples. These learning outcomes we are going to learn with the subject content. Understand the force with its unit, representation, characteristics, effects and force system. Utility relevance of this unit with respect to real life. This course provides the scope to understand fundamental concepts of laws of mechanics and their applications to different engineering problems. This course is designed to provide basic understanding about the different types of forces, moments and their effects on structural components, which will analyze different structural systems. Correct analysis is possible only when one knows the types and different of forces acting on the structure. Examples: a stone lying on the ground, a boy throw a stone on a tree to hit a fruit, building, bridge, tree, door, shutter opened by hand push, tight nut turn with a spanner, etc. Walking on firm surface and on a loose sandy ground. Our everyday life activities done by us or by machine become examples of applied mechanics. Labor used the rod to move a heavy wooden log without knowing the principle of lever. These are some of the examples of applied mechanics in our day-to-day life. Knowingly or unknowingly, we are using these in our various activities. Let's see the graphical example. For understanding the applied mechanics, loaded truck moving on a road. The truck is coming on road like this. Now on the truck, one force, that is a propelling force exerted by engine, this engine force. Second, the truck wheels are in contact with the ground. Two contact surfaces relatively slides, so frictional force acts opposite to the propelling force like this. At the same time, total weight of the engine, truck and the cargo is acting vertically downward, that is the self weight. One more force, the truck load is get transmitted to surface through its contact point by a wheel on road, so the road as a surface offer reaction acting vertically upward. So these forces acts on the truck, along with the force system, truck moves forward. So this is a good example for applied mechanics in dynamics. I think you have got the point how the forces acts on object and what are their effects. Here the truck moves forward means the effect of total forces is nothing but the movement of the truck in the forward direction. The subject we are going to learn applied mechanics in the second semester. Before this, you have learned the subject physics, mathematics in the first semester, that is the prerequisite knowledge required for applied mechanics. Now, when you learn this subject in third semester, you are going to use the matter in mechanics of structure, strength of material, knowledge of the subject you are going to use in fourth semester for theory of structure, theory of machine, and in the fifth semester the same knowledge is used to learn design of steel, RCC structures and machine design. In the sixth semester the same knowledge is required to learn the advanced design of structure. Like this, the subject which we are going to learn is having subsequent use in future. For studying applied mechanics, prerequisites are as following: mathematics, trigonometry, geometry, physics, elementary drawing. The knowledge of these subjects, whichever we go on in first semester, the same is required for development of the applied mechanics subject. Significance and relevance of mechanics. Mechanics is the sub-branch of physical science which deals with study of effects of forces on body at rest or in motion. Applied mechanics, the branch of engineering which deals with study of application of different laws of mechanics for the solution of various engineering problems, is called applied mechanics. The knowledge of this subject enables engineer to properly design all types of structures and machines. Applied mechanics is divided into two sub-branches. First, statics, second, dynamics. Again, dynamics is divided into two sub-branches. First is the kinetics, second is kinematics. Now in applied mechanics, our main aim is to study the effect of forces on body. Either the body is at rest or is in motion. When it is in rest, that part comes under statics, and when body is in motion, that parts come under dynamics. Applied mechanics. Now the statics part. The branch of applied mechanics which deals with the study of effect of forces on bodies at rest is called statics. Example, study of different forces acting on building, bridge, tower and road. So the forces coming on these structures transfer to supporting surface. Supporting surface offer reaction. Along with the forces and reaction, these bodies are at rest, means in stable conditions, and we have to study these forces, their effects that comes under the statics. Now dynamics. It is the branch of applied mechanics which deals with the study of effects of forces on bodies in motion. Example, fire from cannon or a vehicle moving on a road. Kinetics. The second branch of dynamics, the sub-branch of dynamics in which the study of force action on moving body is done considering its mass. The force causing motion is taken into account while studying its motion. In kinematics, the moving bodies are having heavy mass as compared to its small velocity. That's why we can't neglect the mass, and while considering the mass, the motion is studied, that is a kinetics. Example, moving loaded truck on a road. Next sub-branch of dynamics is the kinematics. Pure motion of body is studied without considering the force causing motion. Here the mass is very small, as compared to its motion. The mass is negligible, 10 to 15 gram, but the velocity at that time is tremendous, 500 meter per second. So you may neglect the mass and only study the pure motion, that is the kinematics. Example, fire from cannon. Now let us see the example with graphics. A cannon fires like this and the trajectory give the path of the firing, and on that there are different forces, and according to that the trajectory is nothing but the path of the fire. Do you have any question?
Yes, sir. I have one question.
Please.
What is the meaning of mechanics?
Yeah, very nice question. Just we have discussed, mechanics is nothing but the branch of physical science which deals with the study of effect of forces on body either at rest or in motion. So in universe there are various objects, means bodies, and these bodies subject to forces, and the forces create some effect. If you are able to study the effect, it will be better for design of structures and subsequently to analyze the structure. I think you got my point.
Okay, sir. Thank
Are
you.
you satisfied?
Okay, sir. Thank you, sir.
Thank you. First term, space. The physically space is the unlimited expanse of universe in which all material objects are located and all phenomena occurs. Example of 1 and 2 dimensional space are straight line and a plane respectively. If we have seen in 2 dimensional geometry, the plane is the space, in 1 dimensional line and 3 dimensional there will be the volume. Now second term is the time. It is defined by its measurements. Time is what a clock reads. In non-realistic physics, it is a scalar quantity like mass is usually described as a fundamental quantity. The unit for time is second. Third term is the mass. The amount of matter is called as a mass. Basically, mass is nothing but the matter. So you might be thinking, what is matter? Let us recall. The matter is nothing but the something which occupies space, possesses mass, and can be perceived by human senses. Such a matter, when accumulate, that form a mass measured in kg. Next is the particle. The point mass is called particle. It is a concept. In astronomy, Earth is also considered as a particle. Such a small mass which cannot be divided further into 2 parts is known as a particle. Next is the body. The mass limited in every direction having certain shape and size is called as a body. Bodies are of 2 types, regular, irregular. Now rigid body. The body when subject to force action does not change its shape and size, then the body is known as rigid body. It is again a concept because absolute rigid body is not available in universe. Whenever force acts on a body, body changes its shape and size more or less. But in applied mechanics, all the bodies are assumed as a rigid body for their study. Do you have any question?
Yes, sir. I have one question.
Please.
How can we differentiate mass and weight of a body?
Oh, nice. Just we have seen, mass is nothing but the matter or quantity of matter possessed by body, where the mass subjects to gravitational force, that mass converted into weight. Mass is a scalar quantity, weight is the vector quantity. Mass is constant at any location, but weight is going to change as per the location. So these are the differences between mass and weight of a body. I think you got my point and you are satisfied with the answer.
Yes, sir.
Thank
Thank you.
you.
Thank you, sir.
scalar and vector, these are the two types of physical quantities. Scalar. The quantities having magnitude only are called scalar quantities. Example, area, volume, mass, length, density, etc. Vector quantities. The quantities which possesses both magnitude and direction are called vector quantities. Example, acceleration, velocity, force, etc. Units of measurements. In SI unit system, fundamental units, the units used for measuring the fundamental quantities like length, mass and time are called fundamental units. Second, derived units. The units which are derived from the fundamental units are called derived units. Example, units of velocity, acceleration, density, etc. Now velocity. Velocity is nothing but the displacement per unit time, means displacement upon time, displacement as a length, time as a second. So the unit of velocity is meter per second. Similarly for acceleration, acceleration is nothing but the velocity per unit time, means length per time means the unit of the acceleration is meter per second square. Force. An external agency when acts on a body, then the body tends to move or moves or stop if already in motion is known as a force. Force is a vector quantity. It is measured in Newton as a unit. 1 Newton equal to 1 kg meter per second square. Force is derived from Newton's second law of motion. Characteristic of force. First, magnitude. Second, direction or sense. Third, line of action. Fourth, point of application. So these 4 parameters are essential to understand a force completely. Effect of force. When force acts on a body, it creates certain effects as a push, pull means displacements, rotation, moment, twisting, etc. Graphical representation of a force. Force being a vector represented by a straight line arrow in which the straight line length gives its magnitude with suitable scale and arrowhead indicate its direction. Let us see by an example. Suppose a force 20 Newton acts due east. Now how we are going to represent it graphically? Here the references are taken from xy axis and our force AB of magnitude 20 is to be represented. So first of all, take a scale. Scale is 1 centimeter equal to 5 Newton. Then the length of arrow of the force AB, force upon scale is equal to 20 upon 5 equal to 4 centimeter. So the force is shown by arrow AB. Here the arrowhead indicate its direction towards east, and at the same time the force is parallel to it from the reference axis. So like this we are going to represent force graphically. Bose notations. Whenever we are graphically representing force, the forces are designated by a particular method devised by scientist Bose. The space divided by a force line on either sides are denoted or designated with capital alphabets. Graphical representation. Now see here, suppose a force F and this dotted line along with the arrow is the line of action of the force. The space is divided into 2 parts, up and down. Now upper is the A blinking by A and lower is the B. So these spaces divided by the force line are denoted by A and B alphabets. So the force F is called as a force AB. These are the Bose notations. For force system, when we are going to give the Bose notation, now the space divided by F1 on this side A, on this side B. So AB is the force F1. Like this, BC is the force F2, CD is the force F3, and DE is the force F4. Like this, we are going to use the Bose notation for force system. And while applying the force system and Bose notations, you have to follow the clockwise direction. The statement, it states that if a force acts at a point in a rigid continuous body, then it also acts at other points of the body. Those are lying on its line of action with the same magnitude and direction. Let us see how graphically. Here, this is the irregular body, but it is a rigid and continuous body. The body is having point O at which our force F acts like this, which is shown by arrow. Now the dotted line extended on either side of the arrow, this is known as line of action of the force. This force acts at O, but as per the statement of this law, it also acts on other points of the body. Those are lying on its line of action. Let us see. Point A, 1, 2, 3, 4 or nth. The blinking points, those are lying on its line of action, are also subjects with the same amount of the force. This is the statement and principle given by the force, known as transmissibility of the force. Now, a very good example of this, when a locomotive is propelled by engine, the force generated in the engine at ahead, but the bogies connected one by one to the engine, they are also get pulled forward with this force, and this is the use of principle of transmissibility of a force. Force system. When number of forces acts on a body at a time, then the forces are collectively called as a force system, or we may say that a body subjects to a force system. Now, classification of force systems. First, coplanar. Here, this is nothing but the horizontal plane. In this horizontal plane, all these four forces are acting. They are having different magnitude, different line of action, but they are having common plane in which they lies. So, these forces are known as coplanar. Now, these forces are also known as plane forces or two-dimensional forces. Second is a non-coplanar. Now friends, you have seen here one horizontal plane in which these three forces are acting. But in three forces, there is one more plane as a vertical plane, and in that second plane, F4 and F5 forces are acting. These two forces are also the part of the total force system. Like this, the total force system is acting in two planes instead of one. So they are non-coplanar forces. This force system is known as three-dimensional force system, and vector algebra is required for analysis of such force system. Third is the collinear. Now the collinear force system, in which the forces of the force system lies on a common line of action. This dotted line is nothing but the common line of action, and on the line of action these four forces are acting. So these are known as collinear forces. After this non-collinear force system, the four forces are having different line of action and different points. So they are not acting on a common line, so they are non-collinear forces. Fifth is the concurrent force system. The four forces meets at point O, so they are concurrent forces. Their directions may be away from the point or towards the point, but common thing is that their line of action intersect at the common point O, so they are concurrent forces. Next is the non-concurrent forces. These four forces are not meeting at a common point. So they are not intersecting in one common point, so they are non-concurrent forces. Next is the parallel force system. These 5 forces, their line of actions are parallel to each other. So they are known as parallel forces. The parallel forces are again subdivided into 4 types, like and equal. So here P and Q, two parallel forces, they are having same direction, so they are like, and their magnitude is also same, so they are equal. P equal to Q, so like and equal. Next, like and unequal. The P and Q forces, they are having same direction, so they are like, but their magnitude is not same. P is not equal to Q, so they are unequal. Next, unlike and equal. Unlike, their direction is not same, so P is upward, Q is downward, so they are unlike. Parallel, but their magnitude is same, P equal to Q, so they are equal. And the next, unlike and unequal. Their direction is not same as well as their magnitude is also not same, so P is not equal to Q. These parallel forces are known as unlike and unequal. Significance and relevance of mechanics. We have seen up to this, the mechanics is the branch of engineering which deals with study of various laws, principle, theorem of mechanics to be applied for solving various engineering problems, and its significance is that once you know the knowledge of applied mechanics, it becomes very easy to analyze, plan and design structure. Importance of applied mechanics. In our day-to-day life, various forces acts on a body or structure, and the effect of that forces must be sustained by the force components. So we have to design properly the structural components, the material is selected properly, and for this purpose the applied mechanics is very, very important. Subsequent subjects as the mechanics of structure, strength of material, theory of structure, theory of machine, RCC and steel design, or even the advanced design of structures, this basic knowledge of applied mechanics is required equally. Basic terms in applied mechanics. We have seen from space, then time, particle, matter, body, rigid body, all these are the basic terms which develop the subject applied mechanics. Physics, physical quantity with their types. So there are two physical quantities, scalar and vector, we have seen in detail. Concept of a force and force system. From Newton's first law, we have derived the definition of force. Again, number of forces when acts on a body simultaneously or at a time, then the total forces collectively known as force system, their types from collinear, non-collinear, concurrent, non-concurrent, coplanar, non-coplanar up to parallel. Principle of transmissibility of a force. This principle is very important. When force acts on a body at a point, at that time the line of action of the force passes through the body, and those points of a body lies on its line of action, same force equally acts at all the points. Now you have fully competent to solve the questions of mechanics and force system. So worksheet is given below, try to solve it. From the knowledge just we collected, you are able to solve. Solution of worksheet is provided for cross verifications. Now check your answer with the solution provided. Here you have to write definition of applied mechanics. what happen? Students make mistake. They may write only study of bodies, or they may write study of forces, or they may write the study of motion. So instead of writing in a discrete manner, you have to write a proper definition given in our solution. Now in this question also, you have to differentiate between the fundamental units and derived units. Now students make confusion. They may write MKS, CGS. These are the different unit methods. Here we have to differentiate between these two basic fundamental and derived units as given in our solution. Otherwise what happen? The simple thing, but there will be mixing some fundamental units and some derived units. Don't do like this. So you have to write only the fundamental as the 3 separate units and derived units you take as given, or even though you may write acceleration, velocity also. Now here also the differentiation between two quantities, scalar quantity and vector quantity. So you have to write one by one the points, differentiation between these two quantity. Don't write additional information about the scalar or about the vector. We have gone through the total content of this module. So I would like to say you, try to understand the basic concept. Visualize in mind the practical example of the course. This applied mechanics is a very practical. All our activity are become examples of applied mechanics. So it is very easy to understand. Always use units properly for quantities. Number of times the units may not be written. While solving the problem, the student give the answer but doesn't write the unit. So you don't avoid the unit, you have to write the appropriate units for each and every quantity. Do the practice for conversion of units for quantities. While solving problem, the data may be given in different units, and at that time your job is to convert the units at the same level and then solve the problem. Otherwise, instead of converting the units, you may be getting the answer, but that may give you the lose the marks. Solve sufficient problems as a practice for perfection. Now this is an analytical subject, number of applications, and even though you are knowing properly the theory, concepts, but the problem may have some mathematical application, geometrical application, so you use these application properly and solve the problems, and you will be expert only when you do the sufficient practice. For this purpose, you have to solve number of questions, different types of the problem. You have learned some important topic so far, and we hope you had good time learning with us. Browse through our online library for more content on the MSBT website. Thank you. Stay connected. Happy learning.